Okay, welcome to the notes for even and odd functions. Even functions, they have y-axis symmetry, which we learned about in the video, or not the video, in the lab for Desmos. And even functions make a mirror image about the y-axis. Any point on the function xy is going to have a corresponding point negative xy. So the y's stay the same, but because that the image reflects over the y-axis, the x's have opposite signs. And then algebraically, anytime you substitute a negative x into your function for all the x's and simplify, you're going to get back the original function you started with when it's even. Odd functions have rotational symmetry about the origin. So any graph that is centered at the origin, if you rotate it 180 degrees, you get back the same function graph when it's an odd function. And that rotation around the origin is the same as reflecting in both axes. So reflecting first in the x and then the y-axis would produce the same graph as a rotation of 180 degrees. And that's why the relationship between the ordered pairs, any point x comma y on the graph, if you change the sign of the x and the sign of the y, that shows that it's an odd function. Algebraically, f of negative x is equal to negative f of x. That statement says that you substitute in a negative x for all your x's in the function, simplify, and if it's an odd function, you'll get back the opposite of the function that you started with. Okay, so in example 1, we want to look at each of these graphs. At first, make sure it's a function, and then decide, is it an even, odd, or neither? So symmetry about the y-axis tells us that we have an even function, and symmetry about the y-axis is a type of reflection symmetry or fold symmetry. So if I look at example A, there's my y-axis, and I can see that if I fold the graph over that y-axis, right, it makes a mirror image on both sides. So this point at 2, 1, right, if I reflect it over the y-axis, it corresponds to the point negative 2, 1, and that shows me that A is an even function. Okay, when I look for other functions or other graphs that have this same type of fold symmetry or reflectional symmetry, right here in example C, oh, that made a mess, there we go. Here in example C, we've got a fold or a line of symmetry along the line y equals 2. So any points that I reflect over that line, like here at 4, 0, or sorry, at 4, negative 4, that would reflect over at 0, negative 4. So it does have reflectional symmetry, but it doesn't have y-axis symmetry. And so this would be neither even nor odd. Okay, then in example F, I can see that this graph has a fold symmetry over the x-axis. So any point that I would pick here and here, for example, so this is the point 1, 2. If I keep my x the same but change the y to the opposite, I get 1, negative 2, right? That's the x-axis symmetry, but that isn't what we need for an even function. Even functions have symmetry about the y-axis, and so f would also be neither even nor odd. Okay, when we look at example B, this graph has symmetry about the diagonal line y equals x. So if I were to fold this half over that yellow line, I would end up with a match on the other side. But that isn't a reflection over the y-axis, and so that function would be not an even function. Okay, so I'm going to leave that one alone for a second and come back to it. Okay, then odd functions, they have symmetry about the origin, rotational symmetry about the origin. So if I were to look at a graph that is centered at the origin, for example, D here, right, and then pick 2 corresponding points. So here's a point at 2, -2. Now, if this is an odd function, remember a reflection in the x and y axis produces that rotation of 180 degrees that I'm looking for. So if I reflect in the x-axis, that would bring me up here to positive 2, 2, and then reflect that point over the y-axis, and I end up here at the point -2, 2, which is on this graph. So there's my points x and y, which both the x and the y change signs to get the corresponding point. And that is rotational symmetry about the origin, so D would be an odd function. Okay, when we look at example B, we did say earlier that it had reflection symmetry about the line y equals x, which it did, but this graph is also centered at the origin, and if I pick some corresponding points here and do a reflection in the x and then the y-axis, this point at 1, 1, when I reflect over the x-axis, I would be down here at 1, -1. Then I'd reflect in the y-axis and see we do match up and land at -1, -1. So for that point x, y, we change both the x and the y, and we end up with a corresponding point. So that has rotational symmetry about the origin, and example B would be an odd function. Okay, when we look at example E, this circle here, it does have rotational symmetry about the origin. It also has y-axis symmetry. It has x-axis symmetry. It has diagonal symmetry about the line y equals x. This circle centered at the origin has every type of symmetry that we've looked at in the Desmos lab. However, it cannot be an even or an odd function, certainly not both, because that would be impossible. A function can't be both even and odd. But it's also not neither even nor odd, because remember up here it said first to make sure that what we're looking at is a function. You can't describe a graph as even or odd or neither if it doesn't pass the vertical line test, because those are labels for functions. And a circle, you can see, fails the vertical line test, and so this is not a function. And since it's not a function, we don't even worry about thinking of it in terms of even, odd, or neither. Okay, and then that brings us to the secret question for this lesson, where you're asked to use a graphing calculator, or you could use Desmos or GeoGebra to sketch the graph of each one of these functions, and then determine if it is even, odd, or neither. So we'll go ahead and look at the first one together. So if you go to your y equals, in the numerator we have a -9, and then that's divided by the denominator, and because this denominator is a binomial, we're gonna put parentheses around it. So the quantity x² + 1, right, that denominator has to be in parentheses. Then we'll do zoom 6 and look at the graph. And so this graph, it comes along an asymptote here at the positive y-axis, bends down, and then back up again and up the other side. So if I look at, let's see, we'll do trace, and then I can type in some values here to get some points. So if I put in, like, say, -1, right, I can see I have a point at -4.5. If I put in +1 now, let's see if we get the same y, right? And we did. So -1 had a corresponding point at -4.5. Okay, if we try another set of points, +2 is a -1.8. If I put in -2 and I get the same y value back, then we'll be starting to see that even relationship